Okay, welcome back everybody from lunch. I hope you enjoyed that meal. I'm going to go ahead and get started here with my talk this afternoon. Now, I'm Andy Korinda. I'm a data scientist with Hemlock Semiconductor. Before I get into my talk, I wanted to ask, how many of you do data science or consider yourselves to do data science on a regular basis at your jobs? Okay. And how many of you understand what graph theory is, or at least the concept of graphs in computers? Okay, so don't worry if you didn't raise your hand for one of those or both of those. My goal here is to present an introduction to both of those, as well as some more meat for those of you that do have that experience. So who is Hemlock Semiconductor is one of the first things that I'll get into, as well as the problem statement for the actual use case. Then we'll go through that introductory material on data science and how it applies to my role in the company, graphs and machine learning, and actually getting into the results and that end meat. Hemlock Semiconductor. No, we do not make semiconductors. Let me say that right out front. But we are a very critical part of the supply chain. What we do is we take the metallurgical grade silicon, so it comes out of a mine as quartz. They smelt it down to make what's called metallurgical grade silicon, and we purify that so that somebody can actually pull those big single crystal ingots. Those then get cut up as wafers for solar panels or computer chips. And our company consists of just over 1,300 employees. We have a chemical process and a mechanical process to get to that purity. We're dealing with solids, liquid, gases, a lot of standard chemical engineering. That's actually where my background is in. There's manual equipment and automated equipment, so that's where our labor is really coming into play here. You can see one of our employees here working with the poly and sorting it. And what the product is what we would call 11 nines pure. It ends up being the purest man-made substance on Earth. And that's really what you need to be able to make a crystal. But as specific as our company might be to this in this industry, our drivers are really the same as any of your companies. It's about safety, it's about cost, and it's about quality. Now about myself, here's a little timeline about how I came to be here. In high school, I had a little bit of interest in covert entry. That was a fun way to get some extra time in the computer lab. Yeah, that one got me into some trouble. But then went off to college, started to learn more and more about programming, databases. But this was still all in the context of being a chemical engineer. But you know, these engineers, they learn all kinds of things. So MATLAB, Fortran. Yeah, we have computer programs for chemical engineering that still run on Fortran. And then moving on to my degree in Python, was used for my doctorate a lot. And then moving on to Hemlock, my experience has progressed to R and many other languages and tools. But this isn't the only way that we could present it. It works great for telling a story. We see this all the time in biographies and autobiographies and movies. They tell everything in a linear timeline. Another way to represent that is as a graph. So here's an example of a graph defining who I am. And so you might see some stuff in here that relates to me in another way. So perhaps you speak Spanish, but that's a language. I speak German, and that connects to me. So we are connected through the different languages that we can speak. We might be connected in interests in sports, and that might be directly, you share a sport that I'm interested in, like mountain biking or skiing, but there might be other sports, and it's still a sport, so there's still a connection that way. So it's a different way to look at the same thing, and it removes some of the limitations that a timeline might have. Now, for our company, and the reason why I got into this started with this problem statement. And we, as a people-first company, we aim to hire internally first. We want to promote people through the company, keep them motivated to stay with our organization. So when we went and we said, all right, we're going to do a major expansion, we're going to add 170 new jobs. That's a 12% increase in our workforce. And it's a significant disruption to what we're doing. And for each one of these new roles that gets posted, it's a standard process. We've got to get the job posting approved. We've got to go through an interview process, the selection process. They've got to be trained. Okay, it's an internal hire. Now we've got the extra step of that person's job has to get trained, posted, and they got to get trained. And we got to go through this cycle all the way until we get to an entry-level position. This can add up to a significant amount of time. And our trainers need to know what they're going to have to do as well. So all in all, this could add up to a 20-month time frame, right, as you stack up all these roles to complete that backfills. Plus, during that whole process, we've got our normal attrition going on where people are leaving the company, and we've got to fill their roles as well. And there's stress on the business, right? We've already got orders received based on this increased capacity, so we need to achieve. Now, the solutions that needed to be presented was being able to have the business create and propose these new roles, project how the backfill was going to happen, where are these people going to come from, and what's the chain, what other jobs need to be posted, and then the trainer's time. How are we going to allocate our trainers? How long are they going to need for each one of these positions? How many people are going to flow through these different positions? So, now, to come up with a solution to this, here's another timeline. All right, I really like a lot of math on YouTube. You'll catch that theme here in my presentation. One of them is stand-up comedian, math educator, Matt Parker. He's notorious for his bad Python code. He is very upfront about that. So when he posed this problem of, can you find five-letter words with 25 unique letters? All right, this might be a familiar problem to some of you that enjoy word puzzles. It took him almost a month to run his code. It was god-awful. But he posted a follow-up on how people went and took what he did in the problem and improved it by 40 billion%. What caught my attention was the first improvement, and the largest improvement came in the very beginning. The fastest one to be implemented was using graph theory. So changing this problem, rewording the way the problem was approached, and looking at it all as a graph of connected words and letters. Now, there was also working on HR projects. Next, my group at Reporting and Analytics is relatively new, but we're diverse in the business units that we work with. So I was working in a project related to HR, got to know them and their business and what some of their problems are, understand a little bit more about the problem statement I went over before. I was here at this conference last year, and I got to meet a lot of the people from Neo4j and start digging into graphs and ontology, and some of these words I'll define a little bit more in the future, further in this presentation. And so this was a great place to be and be part of my inspiration. And then finally, actually going and executing the project for projecting backfills. But that's just one way to represent it. And we all know inspiration can be a lot messier than this. So another way to look at the inspiration is through a graph again. And the graph can capture some of the relationships that we don't capture in a linear story or in a more structured database like SQL. It also enables alternative ways to query the process. So common language for querying graph databases is Cypher, and so you'll see a different structure within that language than within SQL. And the way we can traverse the graph has its own advantages, especially in speed for tasks like machine learning. Now, data science in my day-to-day, there's a lot of data, obviously. There's programming, very detailed math, but domain knowledge is a big one that I want to highlight. You need to know your industry. You need to know your business. That's the best way that you're going to identify the problems where you can have the greatest impact. So working with your business leaders, working with those individual contributors at the lower level, having those lunch conversations, and building your knowledge. Right? My background is actually in chemical engineering, as I said before. I started in process engineering, R&D, very manufacturing oriented. And now I've progressed over into the IT field. stretching my knowledge of the business. And then discovery is the other one I'll highlight. Anyone that I work with, I'm always looking for how inquisitive are you? Are you a self-motivated problem solver? Throw a little buzzword in there. Do you have a hacker mindset? All right. And data, we're going through that. Analysis, what kind of models can we use? Trust. This is a big one that I want to emphasize, especially as we talk about generative AI, right? There's all that worry about hallucinations and all that. How are you going to generate trust in whatever solution you propose? An example that I always use as well as an elevator speech. We're a small company. Our elevator goes up 1 floor. You better be quick in how you explain what you're trying to do. All right. And then visuals with an emphasis on self-service in our applications. So now to go through, we want to pick the right model. We want to be able to evaluate it, present that solution, or resolve a hypothesis, depending on who you're talking to and what exactly you're doing. An example here would be regression. This is a really simple one. 1 input, 1 output. Can you draw the straightest line through there? Right? We've all seen this in high school. Well, the advantage to computers, we can do this on much greater dimensions. We can have 12 inputs and 1 output. But what's going on is in the background is the same, right? You're trying to minimize the difference between your prediction and the input data. Okay. Another one is classification. So you're taking a topic and you're refining it to greater and greater detail. So here's an example with sports. You have racket sports or bat sports. You could choose other ways to do it if you want to start with ball sports and track and field sports. Okay. And then finally there's clustering. So an example here is a visualization of a graph of Wikipedia. And they've created 3 clusters here based off of American films, Indian films, and South Korean films. And so we're going to focus more on this clustering type with the solution that I'm showing here today. We'll talk a little bit about how I characterize it, what statistics I used in the process, and I'll show you some of the visualizations that we deployed at the end for our users. Data coming from our HRIS, right? And the analysis, we'll go over these words a little bit more, is adjacency and degree were 2 main things. So understanding the properties connecting items in my graph and counting those up. Trust, I achieved that here through writable math. Could I write out the mathematical equation, and then could I go a step further and write that in plain English? That was a great way to be able to emphasize what I was trying to do and how we were respecting that individuality of a person while doing it. And finally, the visuals that we came up with were graphs, ended up being a great way to represent this, as well as tables for the self-service element. Now, what is graphs and graph theory? Well, graph consists of objects or nodes or nouns, and then they're connected by relations, edges, verbs. You'll see those words used. And these can have attributes or properties. They can be directed or undirected, and I'll use the word ontology here a few times. And that's just saying that what is my designated representation of what I have. This all started with Euler. You might have heard 7 bridges of Königsberg. And so an example here is all of my bridges are my edges, my islands are my nodes, and how do I choose to traverse them? This would be an example of an undirected one. It doesn't matter which way I go. But if I'm looking at my HR system, right, I move from one job to another. I don't move, it's not an arbitrary thing in which direction I go between role A and role B. And for those of you that are really nerdy, this is going to be an application of algebraic graph theory, and this is just adding in first principles element, right? We want to make sure that we have the right constraints so that we don't have a model that's predicting someone will go immediately from an entry-level position to the CEO, All right. Now, an example of a graph and something we might query is, what's the most subscribed YouTube channel by today's attendees? All right. So we here as people are attendees of the conference. We would subscribe to a channel, and those channels are hosted on YouTube. Machine learning. All right. This is, XKCD is one of my favorite things. But the aspect here is just, you're taking a matrix, you're using linear algebra, stirring it all together, and you're getting an output. The linear algebra is creating the layers of the machine learning. And we're using the career path today to kind of expose what that matrix is and how the math works. If you were in one of the sessions this morning, then you might have seen this distinguishing refinement of artificial intelligence to machine learning to neural networks. And they're all driven by the same math. It all depends on what your input is and what you're looking for the output. But it's really all driven by the same principle of linear algebra. So talking about our graph and our path, right? We have a career path that we're taking. Here's an example of two paths that an outside hire might take to become an operations supervisor. And it's the same concept for other businesses, like some of our web sales platforms, right? Someone comes and visits the website, and then either they'll leave or they'll complete a purchase. That's another path that someone might take that could be analyzed in the same principle. It's just a slightly different data set. And so we're able to take this and turn it into a matrix by understanding what items are adjacent to each other. And we can look at that as a structured element to help us understand a little bit of what's going on. So we see a region that would represent more demotions. We see a region that might represent more promotions, and on the diagonal, we have the actual positions themselves. And then on the bottom, we have the hiring process, and on the right, we have the termination process. So, but a matrix is now what you can actually do math with and algebra on. And so what we're going to do is we're going to take that matrix, we're going to multiply it by our actual positions, which are our variable, and the result is how many people are needed to go through each position to achieve our goal. Okay? And if anybody here is technical and interested, the outside hire element has a few extra considerations that I'm open to discussing separate from this. All right, so now that we have this, we can stack these as well. So if we stack them over time, we might call this a recursive machine learning algorithm. Okay, so for example, how is my hiring process evolving month to month, year to year? Okay, we could also change this so we're not looking at layering it by time, but we're layering it to see different sensitivities. So that would be an example where we'd use more of an attention matrix. And that's the same thing that's used in generative AI, okay? It's all coming back to the same principles, and we're just trying to show how it all works. So in the graph here at the bottom for machine learning neural network type thing, we've got our blue input matrix. All the lines cross and do a bunch of crazy stuff. That's really just representing this multiplication. You get another matrix. You repeat that until you have your desired output parameters. Now, inside of the matrix for our particular use case, we're looking at the number of people that traversed the lead operator role. So how many people were lead operators? And we're multiplying this, this is equal to the probability that someone became a lead operator from the trade operator role times the number of people that traversed a trade leader role. So you can see how all these equations become connected. Plus you have the same equation with all the other positions that could lead to lead operator. We have a weighting that I'll define on the next slide. And then we have to consider all those separations that I talked about before. So people who leave the company matter to us. And so by traversed, I mean I'm counting how many edges are of a person to that job. So how many people ever held that job is going to be the number of people that traversed it. And so if you ever look up graphs and the science behind this, that would be called your degrees in. Okay. The probability, that's using our data or weight of a particular source position. So it's saying that I've analyzed my graph and 30% of my trade leaders, let me say that the other way around. 30% of my lead operators come from the trade leader position. Okay. The weighting, so in this case, we ended up using the number of edges of a person that ends at a given position. So at the end of the month, at the end of the year, at the end of my analysis, how many trade leaders do I have? And that was part of the input weight and goal that we have available as part of self-service. Separations, we're counting the number of edges that go from a position to that external terminated, separated node, and that's a degree out. Now, another YouTube channel that I really like is 3 Blue 1 Brown. Earlier this month, he put up a video, and I kind of just wanted to play that video as my entire presentation and skip all this, but the math that he does there is specifically around the generative AIs. And he's showing here the weights, so that's exactly the same matrix that we just went over on the slide before, right? His variables are our positions, and the result is what we just talked about, the number of people that are going to go through there. Now, to get back into the graph side of thing, I need to explain a little bit on how we structured our graph. And this is going back to the ontology. This matters because we want to maintain the correct context and understand the lineage of how people got from A to B to C. Okay. And this was specific to our use case, as is just about every ontology, because we need to make sure that we can extract the data, run the machine algorithms that are relevant to the problems that are being asked of our business. So an example that I have up here is from the European Data Science Academy. And so they came up with a system, and it's available online. You can upload your resume, list your skills, and potential employers can go in there and they can search it, and it's using a graph database to help it match employees with employers in a language agnostic method. So for our application, we changed it up a little bit, and we kept it as directed, like we saw in the other thing, because we care that you went from A to B, and that you didn't go from B to C, or sorry, B to A. All right. We found that to maintain the integrity of the lineage that we wanted, we had to index our edges by the people. So we didn't just have one edge going from job A to job B. We had, for employee 1, job A to job B. For employee 2, job A to job B. And then we could summarize that to create subgraphs. So combining elements of my graph and sectioning it off so I had a smaller amount to work with and I could optimize my algorithms and my speed there. The adjacency matrix, I'm creating the matrix that I set up before based off of parameters of how it's connected. So I said before, how many people traverse that specific edge? What was the probability that they would use that edge over another one? And this could be implemented as the total number of people that use that, or it could be a percentage. We also went for a higher density. So that's saying how connected are things in my graph. So if everything is connected to everything else, that's a density of 1. If you have no edges at all, that's a density of 0. And in our case, we found that we needed to connect people to their organization, level 2 and level 1, not just their job title, and the job title then to level 2, the level 2 to level 1. Okay, we had to include that extra density, be able to get the subgraphs, get the data that we needed to answer more questions. Okay, be able to answer the questions of how people are moving from one organization to another, not just from job to job. So what did we end up doing at the very end? So the process that I created we took in everything from our HRIS, which was the job history and the org hierarchy to create our main graph. Then this would be subsection, and either by area, job range, time, depending on exactly what the question is that we want to answer. And then we would do our multiplication that I presented. This could then be repeated as needed, depending on what you're trying to do. Are you trying to look month-to-month changes based off of a monthly hiring plan? Do you just care about what it's going to look like next year and you want an overall summary? You only want to do it once? Do you want to do a sensitivity analysis and say, hey, this isn't just integers coming out, I need to round these. So let me adjust what I'm seeing here and come up with a few proposed solutions. Finally, we chose to calculate the external elements of this separately from the internal part of the company. That worked out better just for what we were trying to answer. And once we had that all done, we created two different outputs. That one would go into a cipher, into the graph database, so that the analyst could use Neo4j and look into it in a little bit more detail and have free-form analytics. We also have our BI tool at our company is Spotfire, and so we made sure that we could upload into that as well. And that also generated an HTML input, and that we could loop back into the process. So we had a self-service loop as a part of this. So they can do their own sensitivity analysis. They could run this algorithm without having to come back to the reporting the analytics team for every little question. And the managers could run it as well. So in the end, we have our backfill projections. And we were able to answer the questions. How many people needed to be trained? So that's the number of people traversing the position. So it was represented here by how thick that line was. And the user could go in, they could click on any of these, see it, outputs as well. What experience did people come in with? I didn't have that one up in the beginning, but that was relevant to our trainers, right? They want to know if somebody's coming in from a very relevant position, they might only need 2, 3, 4 weeks. But someone coming in from a different department, they might need 10 weeks, 12 weeks to train for the same job. And so that was important for them to be able to find out. So showing all the individuality here was important. And then finally, we had the user adjustable weights. So we let our end users be able to adjust the expected turnover of each role. So how many people do you expect to leave? This was for HR as they implement new measures to try and reduce turnover in specific roles, and they have those initiatives. They could set up their expectations of how they would impact the business as a whole and be able to analyze the results there as well compared to an actual quantified expectation. We could also adjust the backfill source to say, hey, we know we've hired a lot of people from this role, but it turns out that they're not that good at the job. We want to hire more from this role. We have better success with these people. And we could also adjust the number of people in each role. So we would be able to say, we need to upsize this group or this group. Maybe we're going to discontinue this group and move these people over to this other department. Now, for the reporting analytics group, right, I mentioned that we had Neo4j available. And so we got into a little bit more of the free form queries that might come up. So an example here is we want to create a career path to get from role A to role B. Okay. There are two ways that we could answer this question. What is the shortest path, right? What is the quickest way someone could get there? And we could present that. And what is the most common point that people have to traverse? So saying that it's really important that you aim for this job if you want to get there eventually. Where this came in handy was we talk about career paths a lot. Companies create them for us, but they tend to be very siloed, right? If you want to be in IT and you want to be in data, you're going to be a data analyst, you're going to do data engineering, you're going to move up to data scientist, and then you'll be a senior data scientist. No, not necessarily, right? I started off in process engineering, I moved to R&D, I moved to optimization engineering, I moved to IT where I am now, right? That's an actual career path. So we were able to tie the career paths we're telling people to go look at to what was actually happening within the company. And then we had the self-service element. Just show a little bit more detail on that. In purple, I've highlighted the career paths that we could encourage new hires to take, right? We have a starting position that's known to be very difficult. And we make no bones about that. We're open about it. It is a difficult starting position. But we want to encourage people to stick with it and show them that there is a path through the company to get to these higher and better positions. And then in blue, we could also look at what was going on with how people were leaving the company. And that helped expose some non-intuitive answers or some stuff that HR wasn't necessarily paying attention to. Because we had that big fat line going from a known hard position to separations. But we had these other lines that, oh, those are actually really important. And they were significant. And seeing this visualization was actually enlightening for them to be able to come forward and have that presented to them on their own. Because we also have a tool that just uses a basic filter to create a noun, verb, noun query. So this graph was made because we said, all right, we have a job code, it moved to another job code or a termination. Okay. And so they could go through this, and like I said, they could look at organizations, they could look at the different, we could create an org structure. So say the job code reports to org 2 or org 1. Okay. And so that made this graph very dynamic. It didn't just end up being for career paths, right? Everything that we collected, everything that we summarized is all the same, but now we have a dynamic org chart and we have a dynamic career path chart. All right. So in summary, hopefully I've shown a little bit of how we have graphs everywhere, whether it's your life, your inspiration, or your jobs. The matrix in the graph is interchangeable, and that leads to being able to do the math behind machine learning, neural networks, AI, whatever you want to call it. All right. Conferences, I'll throw it out there for WIT, are a great source of inspiration. Go network, talk to people, and even inspiration is part of a graph. Okay. And coming up next within the company, we want to integrate this result into the training plan. Some of the goals there would be project the number of hours of training required. So getting into a little bit more detail, not just telling the trainers this is how many people are going to come from a position, but you have this experience, here's how many hours each one of those should take. Creating a trainer demand forecast. So now we can start deliberately scheduling our trainers 6 months out, 8 months out. We know how we need to dynamically change the headcount in the trainer group. And then we'll continue to optimize how this information is structured as new problems come up. This is one of those iterative things that will continue to happen through any project. It needs to be reviewed over and over to make sure you're solving the relevant business problems. No solution stands on its own forever. And finally, Neo4j loves to put this quote up here from Gartner, so I'm going to throw it up as well. But they projected that by 2025, graph technologies will be used in 80% of data and analytics innovations. And as much as this might not be inherently obvious in all the discussion going on, there is a lot going on in that field with generative AI as well as using graphs to ground generative AIs. So even if it's not making the headlines, look for it. You'll actually find a lot of articles about how it's being used. So with that, I want to thank you all for being here, and I'm open for answering any questions you guys might have.
Thanks, really good. So can you talk a little bit more about the process of taking data from your Thanks. Could you talk a little bit more about the process of getting data from your HRIS into the graph? I haven't done that a lot practically, so I'm curious how that went.
So we ended up using NetworkX as a Python package to ingest a CSV interpretation of all the data that we had. Part of that was just a limitation of our existing HRIS system it didn't have a great export. We're actually moving to a new HRIS system to overcome a lot of the hurdles that we have with our current one. And we'll hopefully be able to integrate that a little bit more directly. The new one's going to have much better APIs and everything. But I think NetworkX will likely stand as a lot of the main ingestion tool. How we'll get its data is going to change, hopefully, from a CSV to something more structured. But yeah, NetworkX, that handled all the graph generation, and that generated as well the Cypher output and the Spotfire output that it needed. So,
David?
Hi, David Corliss, GTE Energy. Great presentation. I think this technology has so much promise and impact. Looking forward to seeing a lot of this at DT Energy, especially. I think Neo4j really stands out. Got a question for you. There's an old saying, I think a lot of us have run into it, about getting a job, that you can't get a job without experience, you can't get experience without a job. I find that's true for technology. I find that's true for tools also, that you can't get the company to adopt graph technology unless the company has already adopted graph technology and seen the results. How do you break through that? What are the opportunities to get that first job so that the company can see, look, here it is, and look, it's produced some good results for us to allow it to grow? Once graph technology gets introduced to a company, I've seen it grow very quickly, but that first project, how do you get it started? What are the opportunities?
you're right. The first time our company looked, our IT department looked at implementing graph databases, I think it was back in like 2019-ish, they turned it down, flat out. They said, no, we're not ready for that. We don't see any advantage in that. We're gonna stay with SQL. We're gonna stay with NoSQL and those more tried and true, I'd say, in a way. Not that graphs are that new, but I think an advantage that I had was we're a relatively small company, especially on the professional side. And so reputation, your own reputation counts for a lot in that case. And so networking within your own company, making sure that you have the support. The other thing I'll say is be ready to present how you want to abandon your project at any time. So at the very beginning, yeah, I set out how I was going to measure success, but I also set out the benchmarks for if X, Y, or Z happens, I'm walking away, I'm throwing away all my work, and I'm gonna go with that, okay? And that was another way that I established trust with senior management to let me spend my time on this. So they knew there were other avenues being pursued, not just this, and that I was ready to accept them at any time and minimize our investment.
I'm sorry, Andy. Just two things. First, great presentation. Didn't know you'd be talking today. I am with Neo4j, and we happen to be right over there as well, if anyone wants to chat with us afterwards. My question was, how did you choose the data visualization platform you leveraged for this? Was it something in-house already, or how did you make that? Because the visualizations were very cool. I'd love to dig down deeper from that perspective as well.
So the main driver in the selection was using what our customers were already experienced with. So in our case, we didn't want to create a new BI tool that they had to use just for this application. We wanted to stick with what they were already used to with Spotfire. One good thing that Spotfire has done recently is they've added more package visualization, so we're not waiting on software developments and software updates to create new visualization options. There's actually a community creating those, and we can upload those. And so the graph that you saw was a package that you can download from Spotfire that automatically creates that. And it is slightly dynamic in how you can manipulate it, similar to Neo4j Bloom, but it is definitely not as powerful in the way it can aggregate or connect queries the way Neo4j Bloom could.
Super cool. Thank you.
Anyone else have a question?
Hello, my name is Akanksha. I'm a student at Oakland University. Thank you for the presentation. I have a question that you yourself have said that you've had an irregular career path. So my question is, how do you account for irregular or unpredictable career paths in your matrix model? And a follow-up to that, any concerns of bias or discrimination in hiring because of that?
So I'll start with the second part on bias and discrimination. We've tried to be very specific that we are just looking at the existing paths that people have taken, and everything that we have individualized the past by the person, but all of that has been anonymized and the PII removed. Now, the data set could be inherently biased from problems in the company previously. And that's why we didn't mean this to be an entirely predictive tool in the sense that it would dictate the company's decisions, right? We wanted to help them understand the backfill hires that would have to be made and not the people that should be hired for it, if that makes sense. So we are strictly we're also looking at the past that have existed, right? And in our company, honestly, my path is not that unusual, all right? My group is 4 people. One's a mechanical engineer, 2 are chemical engineers, including myself, and the 3rd is the new hire that's actually a computer scientist. So, and if I look through our HR department, right, we have engineers in there. In finance, procurement, people have moved all over the place. We have someone that started off as an equipment operator. She's now the quality manager. All right, so all of that history has been maintained in the process. But if there is any discrimination or bias in the past, that would still be in there, would be tied into the predictions, and why we don't want to use it to dictate what happens. We just want to make the business aware that you're going to have to open up these following positions so that we can free up the movement of people. The business still has to be responsible for selecting the right people for the job and making sure that things happen and they don't just take what an algorithm says as gospel. I'll never advocate for that. So.
This might be a little too specific, so please feel free to say no. But so you have these graphs. Have you explored any of the spectral properties of the graphs? By spectral, I mean like eigenvalues associated to the adjacency matrix to either the graph or the subgraphs. And again, if this is too specific, I'm happy for you to just say no. But
so, given the business problems that we have, I did a little bit of exploratory around that, but it didn't produce any results relevant to current business problems.
Kind of 2 questions. One, did you have to go through any of the model risk management where they had to kind of inspect everything to make sure it's in compliance, there's no biases? I don't know if that exists or not at your company. And then 2, can you talk a little bit about the data that you pulled out of the HRIS? How did you go through the cleansing, quality, data logic in regarding to making sure what's being inserted into all of this is, it's not just garbage in, garbage out, but it's actually clean data. I deal a lot with that with my job, and it takes a lot of work to get the final product of the data to be able to use it to whatever analysis you want to insert it in. So if you're able to talk about that.
So being a smaller team, we do keep some of this work internal. So you'll see here that some of the self-service stuff I presented doesn't necessarily dictate all the values that come out. We want them to come to us for some of those answers so that we can maintain the context to help address some of the items and filter. Because we're the experts in the process and the tool, we understand where that discrimination and bias might lie better than the HR department will. So we want to filter that through conversations. We're tied very closely to them. The HR team in total is about 9 people. So we can all work very closely together. For the data quality aspect, cleansing of PII. So we have a TIPCO data virtualization layer is what we call it, that's handling the pipeline process. And that's doing the filtering on the PII. and then the code that I wrote to ingest it into network X is handling the known data quality issues. Some of the common ones that we ran into was that HR would enter a new person, record their job move, and they would have a typo in the job title. And classically, I think some of you are nodding along and seeing where this is going. They would catch it, right? Because it wouldn't work in their payroll system, because, hey, that job doesn't actually exist. So they would change it. Well, that would create a new record. And so, hey, they moved from a job that ends in S to a job that doesn't end in S. No, that wasn't a real move. So we used a time bracket to filter a lot of those out, right? People aren't going to move to a new job within a payroll period, right? That is strictly forbidden. That would be an extreme special case if that happened, because that's all kinds of finance implications and whatnot. So that gave us a hard stop that we could filter off of. All right, any other questions? And we'll kind of, we need to wrap it up. And I'll be around for all the additional questions you guys might have. I really appreciate the discussion here. Thank you very much for being here.